Hello marine engineers. In this module we are going to discuss about the entries that we are going to make in the logbook. So there will be different entries when we are sailing. There will be different entries when we are doing port operations. We will be having different entries when we are having anchorage. We can have different entries. So the first operation that we are going to discuss is during a sailing passage. How will you fill the logbook? Most important machinery that is running during sea passage is the main engine, right? Because your sea passage is completed only when the main engine is running. So main engine RPM, main engine parameters, exhaust temperatures, the jacket water temperatures, the other temperatures like your lube oil temperature and pressure, turbocharger parameters, etc. are very important when main engine is running. Apart from that, generator parameters, yes, important. Fuel consumption important when your main engine is running. So flow meters are also important when they are entered into the logbook, and their parameters are also needed to be indicated when you are doing a sea passage. Okay, let us see from the logbook how will you fill the data during a normal sailing period. Okay,
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mother.
so first in the logbook you can see, let us take a time from 12 noon to 4 this. Okay, watch is 4 hours watch. So let me remind you one thing, that on vessel you do not need to have always 4 hours watch. The days can be advanced or retarded. If it is advanced to 23 hours, your watch will be, say, reduced, timings will be reduced. Say in the midnight they have done a watch reduction, at that time your watch can be reduced to 3 hour 20 minutes like this. So you will have to make 3 watches of 3 hour 20 minutes. The days are advanced, in that case 25-hour days. Generally on the vessel you will have 1 hour advancement or 1 hour reduction in the days. Generally they do this 1 hour reduction or advancement. So if they are retarded 1 hour, your days will be 25 hours. So according to that, your watch timing will be decided. So that you have to make entry into the logbook also. Okay, why it is important? If you have written 4 hours, say, but your machinery say has run, the counters has run for only 3 hours 30 minutes or 3 hours 40 minutes, so there will be the difference created. Okay, in this logbook it is not shown the counters here, but the counters will be important when your timing is varying. Okay, in this logbook you can see the counters are written. Okay, in this logbook you can see the counters. So one counter and the other counter will have a difference. Okay, through the difference in the counters we'll come to know how much RPM, how much revolutions has the main engine moved in the whole day. Okay, in the 4 hours period, and from the complete difference from this noon figure to the previous noon figure, through that we will come to know last noon figure. We'll come to know in whole complete day how many RPM the vessel has moved. Okay, and multiplying it by the 24 hours period, you will come to know how much distance has the vessel moved according to the engine distance. Okay, average RPM is the RPM that we will take from the RPM counter, okay, of that watch. Now engine room temperature you will have to take. Seawater temperature you have to locally verify from near the seawater pumps. Fuel index you will check from the governor. Okay, governor fuel index. Fuel oil pressure, you need to check pressure and temperature near the main engine inlet. Okay, this is the main engine inlet fuel oil pressure and temperature. Sump level is very important, because the sump oil is transferred from the sump into the bearings, main bearings, trosset bearing, other bearings lubrication, and also to the piston cooling. So sump level might reduce. You do not completely rely on your main engine sump low level alarm, because that is a sensor and can be faulty at any time. So physically the sounding has to be entered into the logbook. That is why it is important when main engine is running to check the sump level and enter the correct value in the logbook. Then this lube oil and jacket water pressure can be taken near the pump. Okay, jacket water pump and the lube oil pump. the pressure should be in the range of 2.6 to 2.9 as it is mentioned here. Okay, lube oil. Now come to the temperatures. So these are pressures in the bar. Okay, 2.6 bar, 2.9 bar. Now the temperature, lube oil temperatures. Lube oil inlet temperature around 40-45 degrees and the outlet is 50 degrees. So important thing is the difference between the two. The difference between the two should not be so huge. That means that the lube oil is somewhere getting heated up, or some hotspot is forming, or maybe the bearings are not getting the adequate lubrication. That is why the piston cooling oil is not getting adequately reaching the piston for cooling. So in that case the difference will be huge in this case. So that is what your inlet and outlet should be in a range, and the difference should not be, you see the difference in all the watches are almost similar. So that means your piston is adequately cooled and your bearings are adequately lubricated. Okay, now the jacket water temperature, outlet temperature. The inlet temperature is not important for us, outlet is important. Why? Because all the units should have adequately similar values around 80-81 degrees. Why it is important? Because it signifies that the lubrication breakdown has not taken place in the piston, between the piston and the liner, or any of the jacket is not leaking. In that case what happens, the combustion gases will go into the jacket side and the jacket water itself will get heated up. So jacket water temperature, jacket cooling water outlet temperature, after it has cooled down, the outlet temperature of the jacket water, you can get it from the local temperature gauges fitted in the engine manifold. In the engine manifold near the jacket water outlet line, you will have all the gauges, inlet gauges and outlet gauges also. Outlet gauges are important for us because after heating up, how much is the temperature. Okay, now secondly you can see turbochargers. Since the turbochargers are now running during this rpm, the turbocharger was running at how much? 9823, 9823 is the turbocharger rpm. Okay, so this is the rpm they have mentioned. Okay, since the turbochargers are oil cooled, these sections are kept blank, so that is why they have only one turbocharger in this vessel. So they have mentioned only one turbocharger rpm. Now the temperature. So in this, since exhaust temperature was not there in the section, what the ship staff has done, they have mentioned exhaust EXH and they have started writing the exhaust temperatures. Inlet to the turbocharger and outlet to the turbocharger. Okay, inlet is 440 and outlet is 340. Okay, so you see there is a 100 degrees drop in the turbocharger exhaust temperature when it has crossed through the turbine blades. Okay, obviously the temperature will drop because the pressures have dropped, the exhaust has been used to run the turbocharger, temperature has to drop. So there has to be a significant drop and that has to be monitored. That is why it is entered into the logbook. That will signify your condition of the main engine turbocharger, as how much well the turbocharger is functioning. Second is your seawater cooling. Okay, air coolers. So this, since this system is air cooler is seawater cooled, your cooler's temperature is also important. So seawater inlet temperature, inlet is going to be the same as the main seawater temperature. Why? Because there is no obstruction in the line, the seawater is same, is going into the main engine air cooler. Main important is the outlet temperature. So seawater outlet temperature from the air cooler will tell you how much is the going to be the scavenge air temperature. Okay, or what is the condition of the cooler. If your cooler is clean and tidy condition, okay, then there will not be a big difference in these two temperatures, or it will be moderately same in all the watches. Okay, so that means your seawater is going inside and scavenge air is absorbing the heat, it is absorbing the heat of the scavenge air, and then the return water is getting heated up in turn. Okay, so that is how you will observe this seawater cooling temperature. Now come to other um, parameters. Starting air pressure, how much is this, you will take from the air bottle, 21 bar. Scavenge manifold, scavenge air pressure, how much? 0.8 bar. What is the scavenge air temperature? 50 degrees centigrade. Now this is the fuel oil settling service tank temperature, 62 degrees settling tank and service tank 77. Okay, thrust bearing temperature, This you will get from the local gauge thrust bearing temperature. Intermediate shaft bearing temperature 42 degrees centigrade. Okay, now come to the so they have also mentioned 0 to 400 Indian room normal watch keeping routines and carried out, and they have given their signature. The watch keeper, third engineer, was during this watch, so he has given this signature. One important thing you can see in this logbook, since we are out at sea, we can run the OWS. So chief engineer has started the OWS and he has put the signature also. Engine room rounds were taken satisfactorily and chief engineer's signature is there. At 1100 hours local time, OWS was started for overboard discharge through the 15 ppm equipment or plant was also mentioned by the chief engineer in the logbook. So these are the entries that has to be done by the, apart from the duty engineer, the chief engineer also makes entries into the logbook. Now second, other part of the entries we will see in the next video, guys. Okay, thank you.